Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry will be helpful for the international entrance and any competitive exam you are preparing for. India level JEE Advanced and JEE Mains for IIT and NIT entrance exam for engineering stream. It is the technical domain. NEET chemistry for medical entrance examination, Telangana and Andhra Pradesh MSET for the engineering stream, technical stream again. In addition to this one, if you are aspiring for any kind of examinations conducted by government organizations, where you can find general studies as a common paper, and in that general science content will be there. The kind of session what we are discussing will be very much pushing towards that kind of preparation strategy, right? Let's dive into our today's session. Explain the name of the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per the IUPAC, we have to name the given compound. Here, so many options are there among 2-bromo-6-ethyl octane is the right nomenclature for the given compound. Let's see how can we assign the name for this in accordance with the IUPAC protocol. In order to name this one, we have to go for the direction, what is the correct direction in order to assign numbering. Either from left or right, two provisions we have. If you are starting from left hand side, the substitution will be accompanied at if you are coming from the left hand side, substitution will be on the third carbon atom. But from the right hand side, if you are coming, so that in the second carbon itself, you can find the substitution. So this will be the right preference. Numbering from this right hand direction is the right preference in order to assign the numbering. Whenever you are starting numbering, need not to go for this is the carbon number 1. If you are mentioning this is the carbon number 1 and the length of the chain will become 7 only. So that longest chain of carbon will be the higher priority that will become as a parent chain. So that you have to start numbering from the carbon whichever present as the side chain over here. So carbon number 1 and the second carbon is accompanied with the bromo. Third, fourth, fifth, on the sixth carbon you can find ethyl. Seventh and eighth. This is the way you have to give the numbering so that 8 carbon length chain it will be, and bromo on the second, ethyl on the sixth carbon atoms. This will be the representation. So after getting this kind of numbering, after assigning numbering to each and every carbon atom, now we have to go for alphabetical order of arranging the name. Being ethyl and bromo, B comes first over ethyl, so that 2 bromo can be the first one. 2 bromo. Later on, go for 6-ethyl. Ethyl located on the 6th carbon, so that 6th ethyl to be mentioned. And the parent chain will be 8 carbon of length without any double triple bond, so that octane. 8 carbons denotes octa, and being it is a saturated, no double bond, triple bond, so that ane will be the suffix. The entire name will become 2-bromo 6-ethyl octane. This will be the right naming. 2-bromo 6-ethyl octane for the given organic compound in accordance with the IUPAC. Question number 1, option number C will be the correct answer. Move on to question number 2. It is collected from Cambridge Assessment International Education. Which row shows the waste products released from the exhaust of vehicles powered with a hydrogen oxygen fuel cell? Hydrogen oxygen finds a potential applications in the space traveling devices, and even in the daily life organized devices. We can say they are saying about exhaust of vehicles. They are also consuming hydrogen oxygen fuel cells, and in the near future, hydrogen will become the fuel of the future. There is no doubt, definitely it will be because of two factors. We can say one is said to be hydrogen is of high calorific value, first condition, and the second will be no waste products during its combustion. Whenever it is combusted, water will be the output, so that we can't say it is the kind of environmentally degrading, rather it is eco-friendly in nature, so that it is obvious to get a fuel of the future as a hydrogen, being it is the potential in giving high energy without any harmful emissions, right? So what they're asking, what is the exhaust? They are asking for the waste exhaust generated by that one carbon dioxide. Obviously, no. Oxides of nitrogen, no possibility over there, being it is the hydrogen oxygen itself. Simply they combine to give the water as a product, so that we can cross for carbon dioxide and oxides of nitrogen, only the provision for water. Water is the probable product, and being it is the product of this fuel cell, it can be consumed, it can be retrieved, and can be applied for any other applications as well. So this is the way hydrogen oxygen fuel cell is more efficient in terms of energy efficiency, in terms of what we can say calorific value, in terms of waste products generated. So that let's see the detailed description about the fuel cell first, later on how can we construct and what kind of fuel cell it will be. Fuel cell is the kind of device where you can convert chemical potential energy into electrical energy. Fuel is supplied continuously. Here you can clearly notice hydrogen gas is bubbled over there. Oxygen is bubbling from this right hand side. So that whenever these chemical components are injected, so potential energy, chemical potential energy, which hidden in that can be transformed into electrical energy over here. So that hydrogen slowly converted into H plus and releasing electrons, oxygen gaining electrons, finally water as the output. Water vapor is coming out from this device. The water is the output without any harmful emissions. We can't notice any kind of oxides of nitrogen, oxides of sulfur, oxides of carbon, nothing else except water. Water is eco-friendly 100% and finds a wide range of applications as well. So this is the description for hydrogen oxygen fuel cell. The waste product generated is water. We can't say water is the waste product, because though it is the output of this one, we can say it is the kind of material and finds further applications. So we can't say it is the waste product from the hydrogen oxygen fuel cell. It is the best product, right? For question number 2, option number D will be the correct answer. Move on to question number 3. It is collected from JEE Advanced 2020 question paper, paper 2. It will be, sorry for the mistake over here, paper 2 it will be. It is a kind of question given from periodic properties where ionization enthalpy is taken into the consideration. First, second, third ionization enthalpies are designated as I1, I2, I3. 4 atoms are mentioned. 4 atoms with their principal quantum number it is given. N, N plus 1, N plus 2, N plus 3. These are called atomic numbers. We have to notice what is that. They are giving like a code signals like N, N plus 1, N plus 2, and N plus 3. Here, one hint is given to you, that is N is always less than 10. In this condition, N is less than 10. We are not supposed to go beyond 10. Below 10 only we have to think about it. So entire things are tabulated here. The value of N to be depicted. So from this data, we have to find out what is the exact value of N. In order to identify, we have to go with the logic behind ionization enthalpy. Ionization enthalpy stands for amount of energy required in order to remove the electron from the neutral gaseous atom. So from the neutral gaseous atom, if you want to remove the electron, certain amount of energy to be supplied. That is said to be ionization enthalpy, and it is measured in kilojoules per mole. And from the atom, if you are removing only one electron, that is called first ionization enthalpy. You are removing second electron also, second ionization enthalpy I2. Third electron also you are pulling out, so that it is called I3, third ionization enthalpy. This is the way you can go for, and atomic number code are provided in N plus 1, N plus 2, and N plus 3. If you observe carefully, for the atomic number N, first ionization enthalpy is 1681, second will be 3374, third will be 6050. If you see all the parameters, what happens? They are not interesting to remove the electron. Rather they are not ready to remove the electron. Rather they have a tendency to accept the electron, it seems. So N denotes particularly non-metallic substance. From this data only it is very clear. Move on to N plus 1. N plus 1 data. So if you observe, first ionization enthalpy itself, extremely higher value 2081. And second ionization enthalpy 3952. Third ionization enthalpy is 6162. 6122, sorry. All these values are extremely larger so that we can clearly confirm it is the kind of noble gas. Noble gas. And move on to third column where you can find n plus 2. N plus 2 is very clear and it will give the hint to you. We can easily trace out what is n over here, right? N plus 2 you can find the 496 as the first ionization enthalpy. It is somewhat less amount of value, and the second value is 4562, extremely larger. It's very difficult to remove the second electron. First electron you can remove, you can pull out, but second electron, it requires large amount of energy, high expenditure. And moreover, third ionization enthalpy is still higher, 6910. So that only you can notice one electron removal is very convenient for you. Right. This is about third column. Move on to fourth. N plus 3 is 739. And second ionization value will be 1451. Third will be extremely larger, that is 7733. From this data, it is clear that one electron you can pull out, even second electron also you can remove. Second electron also some extent, because this is not much higher as you compare with another elements, so that it is somewhat easy to remove two electrons, but third electron it is obviously no. So that we can say this is the kind of element of second main group element, second main group. So here it's very clear, first main group element with one electron removal, and second, third electrons are not able to. So that one electron you can remove, and the value must be n is less than 10. N value is taken as 9. So if n value is 9 plus 2, so that 9 plus 2 it will become 11. 11 is the first main group element. First main group element having natural tendency to remove the electron. One electron you can conveniently remove with the lower ionization enthalpy. This is the way we can clearly identify how can we solve such kind of problem. From the data, N plus 2 atom is an alkali metal. Alkali metal denotes what? First main group element, where you can pull out one electron very conveniently. And that is said to be sodium, because atomic number 11 corresponds to what? Sodium atom, right? So N plus 2 is equal to 11. N is equal to what? 9, obviously. So that this is the way you can solve the problem. Value of N is regarded as 9. For question number 3, answer will be 9. In value will be 9. And atom identified as a sodium belongs to first main group. So from this ionization enthalpies only we have to depict what kind of nature the element is exhibiting, right? So this is the way we can answer. Move on to question number 4. Again, it is a part of JEE mains question paper. Consider the following compounds in the liquid form. All liquids are taken. Oxygen O2, hydrofluoric acid, water, ammonia, hydrogen peroxide, carbon tetrachloride, chloroform, benzene, and this is said to be chlorobenzene. These many kind of compounds are provided to you. Some are said to be diatomic, some are triatomic, some are polyatomic as well. These many kind of compounds are given. You have to analyze all these are under liquid condition. When a charged comb is brought near to the following stream, how many of them show deflection as per the following figure? So if you are taking a burette, burette is filled with liquids of all these different burettes are filled with different liquids which are mentioned over here. And open the knob so that drop by drop you can notice liquid is coming out. Whenever drops of liquid are coming, at that sphere only you can place a comb which is of charged one. Whenever charged comb is near to these droplets of liquid which are falling from this burette, so what happens if the liquid is polar in nature, that polarity will pull the liquid towards the charged comb, so that there is a certain kind of, you can notice over here, droplets of liquid are somewhat somewhat near to this kind of foam. This is purely because of polarity of the liquid. If this is the kind of condition, the liquid is said to be polar, and this is called deviation in its path, right? So whenever the compound is non-polar, it will fall down without any kind of such a deviation. They're asking for how many molecule which mentioned above will have this kind of deflection. Such a deviation you can notice. Among these many, 6 molecules are exhibiting such a deviation. Let's see how can we explain this one. The molecules like hydrochloric acid, water, ammonia, dihydrogen, hmm, what hydrogen peroxide, sorry, chloroform, chlorobenzene. These many molecules are having deflection by the charged cone. That is purely because of their polarity. These compounds are said to be polars. Poles means what? Polar region means what? Wherever charges are separated, those are called poles. Charge separation is called poles. One is positive pole and either negative pole, like this. If HF is there, being it is a covalent, there should be a proper sharing of electrons. But the electronegativity of fluoride is extremely larger, and some extent bond is towards the fluorine, so that partial negative charge accompanied by fluorine and partial positive charge by hydrogen. This is the way you can notice poles over there. And water also having electronegative oxygen acquiring partial negative, and always hydrogen with the partial positive. And ammonia, nitrogen, again the kind of what electronegative, so that it acquires partial negative, and else hydrogens all are accompanied with the partial positive charges. When you go with the hydrogen peroxide molecule, where hydrogen with the partial positive, oxygen with the partial negative charge, you can clearly notice this. This is an open book model. And the chloroform. Chloroform is unsymmetrical, we can say. Chlorides are highly electronegative accompanied with the negative. Hydrogen is a partial positive. Always hydrogen is a partial positive. Electronegativity comparatively less, right? So this is the way you can notice the charge separation. And in case of chlorobenzene, chlorine is more electronegative accompanied with the partial negative, and the rest all carbon atoms are having partial positive in the resonating form. This partial positive is not localized, rather it will migrate from one carbon to another in the entire benzene ring. This is the way we can clearly see polarity among all these molecules. You can notice the charges over there, so that these molecules having such kind of deviation whenever foam is charged and near to its path, so that this is the way you can clearly explain. Only 6 molecules are said to be polar. Those are exhibiting such a deviation. For question number 4, option number answer will be 6. Move on to question number 5. This is collected from Telangana Gurukulam Degree College Lecturer Entrance Examination. Which of the following is the correct statement to define Frank Condon principle? Frank Condon principle is the part of physical chemistry. Nuclear coordinates do not change during the light-induced electronic vibrational transitions. Here, electronic transitions are the part of UV, visible spectroscopy, vibrational part of IR spectroscopy. Whenever such kind, being it is the photochemical condition, photochemical reaction, photo-induced reactions always, so that you can notice electronic and vibrational transitions in the molecule. And nuclear coordinates do not change during the light-induced electronic vibrational transitions. So let's see what is Frank Condon principle first. Frank Condon principle is a rule in the spectroscopy. Spectroscopy deals with how a molecule used to stretch, bend, vibrate, or else any kind of transitions that expected due to the induction of light. So light matters in order to get the molecular internal certain kind of transitions. That is purely explained with the spectroscopy. Spectroscopy is the device which used to analyze the molecule, where it is absorbing the light, where the absorbed light is emitted, what kind of spectral lines we are expecting. Based on that, we can analyze its chemical composition, chemical structure, and arrangement of the functional groups, and what kind of nature they existing. So this spectroscopy is a root system in order to analyze the compounds in the research field and the medical field as well. So that in this spectroscopy, Frank Condon principle is very much important. James Frank and Edward Condon framed a rule where whatever kind of quantum chemistry we are dealing with, in that vibronic transitions mean for IR radiation, right? Vibronic transitions and electronic transitions in the energy levels of the molecule are mainly due to absorbed or emission of photons with a particular amount of energy. Whatever light absorbed in the form of photons are called packets of light, no? So those photons when absorbed by the molecule, certain extent of electronic transformations you can notice, and as well as vibronic transitions also possible. That relation is mentioned by the scientist called Frank and Condon. And extent of transitions like electronic and vibrational transitions are mainly due to the absorbed or emitted light of photons. The principle states that during the electronic transition, change from the vibrational energy levels are possible because electronic transition is accompanied by vibrational, rotational, translational, everything being electronic transition of high energy consuming one. So whenever electronic transition is possible, vibrational is simultaneously possible within, and rotational transitional also possible within the molecule, right? This is explained by Frank Condon principle. And according to them, nuclear coordinates means different dimensions we have. Those dimensions may not be changed whenever they are undergoing electronic and vibrational transitions due to the induction of light. Whenever molecule is taken, that molecule is irradiated with the light, and it will participate in the electronic and vibrational transitions in the presence of light. But whenever that transitions are possible, whatever its nuclear dimensions are there, the nuclear dimensions or coordinates remains a constant. So that is the kind of explanation provided by Frank Condon equation. For question number 5, option number 2 will be the correct answer. Move on to question number 6. This will be the last question of the session, and it is given from the kind of nature of compounds with respect to the conduction property. It is a kind of electrochemistry question, we can say. Relate the following 5 band structures with the conductors, semiconductors, insulators, N-type semiconductors, and P-type semiconductors. Wider strips are dopants. Wider strips, if present, those are called dopants. Okay. So these many components, these many kind of components are provided. We need to identify what is what. So so here two kind of bands you can notice. Lower band is somewhat intensely colored. Upper band is a kind of vacant, it seems. Lower bands, entire A, B, C, D, E, lower bands are intensely colored. Upper bands A, B, C, D, E are vacant in nature. They are dully filled. This is purely because of all these lower bands are said to be valency. Valency band is nothing but which are accompanied by the electrons that might be partially filled, completely filled, or else only one electron occupied, whatever it might be. Outermost electron laying orbital is called what? Valency shell. That valency shell is intensely colored over here. And whatever band is there in the above region bands are called vacant. They are empty. So they are vacant in nature. They having tendency to accept the electrons. Whenever the energy is supplied, what happens? Always electron. Any person having natural tendency to grow up, right? In terms of finance, in terms of career, in terms of growth, whatever. Always every person having tendency to go forward. In the same manner, here also electrons having tendency to jump. So this electron from valency to conduction band jumping is possible whenever electron is propagating from valency band to conduction band. Electron movement matters for the conduction. So in order to move the electron from the valency to conduction band, there are certain kind of barriers we can notice. In order to see the barriers here, Fermi energy gap matters. If Fermi energy gap is nothing but this is the hypothetical barrier which used to bifurcate valency band from the conduction band. So it is the hypothetical energy barrier, we can say. Energy barrier below which valency bond lays, above which conduction band lays. So if this Fermi energy gap is larger, it's very difficult to jump the electron from lower to higher level. So energy is not sufficient to move there. So that electrons are not moving. If electrons are not moving, so that conduction will be zero. That is said to be what? Insulator. If certain smaller distance is there, so electron will try to move by some way. So this is the way you can notice a certain amount of electrons are moving, so that partially they are able to conduct. Certain extent they are able to conduct because some electrons will try to move, some electrons will drop. So this is the way semi-conduction will be there, partial. And whenever conduction and valency bond both are overlapped with each other, so here if you see no energy barrier, both got overlapped, so that electrons are more convenient to move up. So this is the way conduction is possible very conveniently. Whenever you see the copper wire, silver wire, iron, any kind of metal, this is the case. You can notice all the valency and conduction bands are togetherly overlapped, so that electrons conveniently flow without any objection. This is about conduction property. And these wide bands, if you notice, here wide band is there, here wide band is there, these two are the part of doping. So these are called dopants, they said. So that these two are the part of semiconductors only, but after doping they are generated. We will discuss in detail about all these kind of conditions in terms of Fermi energy barrier. First one is A is the kind of nature. You can notice the larger distance between the valency to conduction band. It is said to be insulator. Insulator is the divide which restrict flow of electrons, which will stop, hinders flow of electrons, so that valency conduction band forbidden energy gap will be there. The gap is that is larger, so that electrons can't move anywhere. So insulator examples are provided like plastic, rubber, and glass. There is no passage of electrons, no passage of current. And this is the way you can, within the problem they mentioned like this, large energy barrier. Insulator, it is saying high resistivity means no conduction. High resistivity means resistance is more, conduction will be zero. That is called what? Insulator. Move on to second, called semiconductor. Semiconductor, the gap is somewhat concised, and with some extent they will try to move up. And this is the way we can see the Fermi energy barrier gap. So this is not that large in case of insulators, and you can notice 1.6 electron volts of difference is there in between conduction and valency band. Semiconductors having partial conductance. At low temperature there is no conduction. So if we are rising the temperature at room temperature, there is a seizable electronic conductivity. You can notice partial conduction, we can see over there, semiconductor with the partial conductivity. If you see the what conducting material, where electricity flows very easily because of convenience of movement of electrons from valency to conduction band without any traveling expenses, right? So conduction to valency band gap is not there, so that overlap, and conductor with the high conductivity and low resistivity. And in either component whichever provided like a large band, so this is a kind of dopant they mentioned. And where you can notice whenever semiconductor like silicon, germanium are the best examples, and they blended with the boron. Boron is the third main group element. They having tendency to pull the electrons from the silicon. So whenever electrons got accepted, silicon will generate hole, means vacant site, electron lost by this, so that vacant site hole will be generated. These are able to generate a P for positive charge on the semiconducting material. Conduction due to holes is possible in p-type. Holes are nothing but vacancy of electrons, which denoted with a positive sign. And this is the energy barrier between valency and conduction band. And here you can see silicon to phosphorus. Silicon to boron is p-type. Silicon to phosphorus is said to be n-type. This is the kind of fifth main group element. And fifth main group element having its natural tendency to release the electron. Electrons will give up. So whenever electrons are released from the phosphorus, free electrons will be generated. Those free electrons will increase the electron density, and so that N4 negative charge will be generated because of electron density. This is the way N type of semiconductor will be generated. So all the mentioned examples are clearly described. A for what? A for insulator we said. So third one is the insulator. You can notice B for what? B for 2 they are saying semiconducting material it will be. C for what? C for 1. 1 is for conductor. No energy gap. And D for what? D for P type of semiconductor will be there. E for N type of semiconductor will be there. For question number 6, option number 3 will be the correct answer. This is the way we can go for, based on the energy barrier, energy bifurcation between the valency and conduction band, we can categorize all these. Hope this session is very much helpful and informative as well. So it will be helpful for your preparation, and if you are following continuously, definitely it is more informative and you can achieve whatever you are expecting for. And sincerely requesting to like the channel, comment which part is important and interesting, share with us parents who are seriously preparing, subscribe the channel to receive more such updates in the near future. Thank you very much for your patient listening. Thank you one and all.